Now that we have an idea of what a force is, we want to talk about what a system is. A system is going to be similar to the frame of reference that we had in kinematics, but it's going to be like a frame of reference for different masses. In order to kind of look at this point, let's look at this dog sled team. Look at these guys, aren't they adorable? Ultra precious. There are really three ways I could look at this dog sled team. I might be thinking of, wow, I really want to get the fastest dog sled that I can. And so I might look at this entire team as one whole system. And I'm going to look at the forces for that whole system, all the dogs and the sled and the person together. I could minimize all of that to a box. And I could say, well, my dogs are pushing on the ground to apply a force forward. And what are the forces that are resisting that? Well, maybe the friction of the dog sled, maybe there's too much weight on it, maybe we need to distribute that weight, maybe that dog sled needs to be longer, things like that. I could look at what's the efficiency of this system as a whole. However, I could also look at just one of these dogs. I could say, hey, this dog right here, I want to think about how good is this dog at pulling that sled? And now I'm just going to pull that dog out and I'm going to go, hey, look at that guy. That dog is pulling on the sled. It's pushing forward and the sled is pulling back on that dog. Now, I want to look more in depth at that because I want to see the strength of that dog. I want to see where that dog needs to be in the position. So I might need to look at each individual dog as its own system. That could be a system. Now, the overall forces moving the dog forward, the relative position of that dog sled, is going to be irrelevant when I'm looking at the dog as the system. If I'm looking at the whole team as a system, then I'm going to look at the forces affecting the entire team. And now each individual dog is going to be irrelevant. There's one more. I could get even more specific, and I could go, hey, I'm trying to design a better harness. See how these harnesses fit over these dogs? Let's look at that harness right there. I could say that harness, where it's hitting the dog, is a system. So the sled pulls back on that harness where it hits the dog, and the dog pushes forward, applying a force to that harness. So I can look at each point of contact. I can see that as my system if I want to think about how can I make a harness that's going to be the most comfortable for that dog to wear. So the system is really something that I'm defining depending on the forces that I want to look at. And there are some very useful ways to look at different systems. For example, in a lab that we're going to do later in this unit, we're going to look at something called a modified Atwood machine. It'll be something that sits on a table with a pulley. And so there's my table, and here's a pulley. And I'm going to have a string connecting a hanging mass with a mass that is sitting on the table. So let's make the mass on the table. Let's make both of our masses. Let's make them this orange color, this burnt orange. Nice burnt orange. Look at that. Oh, it's burning. It's basically burning my eyes. Okay, so I've got two masses here. I've got an M1 and an M2. If I were to just look at M1, so if I just look at M1, I might see it as having this force pulling it to the right, and I might say it's got a certain mass, and I'm going to see a force pulling it to the left, and it's going to have a certain mass. It's going to have this amount of mass, it's going to resist this force and this force, these forces are going to be opposing each other. I can look at those forces specifically. However, that might present me with some troubles. I might need to investigate the net force on this motion. I might need to adjust that net force. You'll learn these terms better later. So I might want to look at the whole hanging system. I might want to look at both of these together as a system. And if I did that, suddenly I would say mass 1 plus mass 2, and then I would have a force of gravity. It doesn't really matter the direction. I'm just considering the forces. I could say the force of gravity is the thing pulling this, and I could say the force of friction is the thing resisting this. So depending on how I define my system is really going to tell me a lot about the forces involved. If we come back to this bobsled example, we're going to learn about Newton's third law in just a minute here. But if we look at this bobsled example, when these huskies apply a force to that harness is applying the same force backwards. Look at that. Look at those forces. Can't really see them. Look at those forces. And those are going to be the same force. If those forces are the same, how could these huskies be moving? Well, because that's not the only force in this system. On these huskies, that's the system forces. But the huskies are also pushing against the ground, and the ground is pushing back against them, which causes the whole dog sled system to move. So it's going to be really important once we start to investigate Newton's laws of motion and how these different forces go together. It's going to be important for us to define the system that we're looking at. Most of the time, it'll be pretty obvious, but sometimes it'll be a little tricky. So we'll want to keep that in mind. All of our laws are going to depend on the system that we're looking at.